All right, guys, it's Mr. Grabo, and we're back with Bill Math, Chapter 5, the mid-chapter checkpoint, questions 13 through 16. And these last couple of questions all focus on short story problems, and they have kind of this confusing part where it says there are between, and then they give us some numbers. So I don't want you to get too confused. We're really just finding common factors. And then we'll answer the question. So here we go. Sean places 21 tomato plants in rows. So we know we have a total of 21 tomato plants. All rows contain the same number of plants. That's really just telling us that we're finding factors. There's none remaining. There are between 4 and 12 plants in each row. How many plants are in each row? So Sean could make his garden a handful of different ways. You could do one row with 24 plants in each, right? So one row, 24 plants. But that's not going to work because there's got to be between 4 and 12 plants in each row. Well, you can't do 2 rows because 2 doesn't fit into 21. He could do 3 rows and have 7 plants in each row, right? Could he do 4? No. 4 times, well, nothing equals 21. Could he do 5? No. Could he do 6? No. Could he do 7? No. So there are blank plants in each row. Well, there would be 7 plants in each row. And 7 is between 4 and 12. So, yeah, so you got it. All right, let's go on to question 14. Ella bought some keychains and spent a total of $32. So, once again, we got $32, right? That's our total. Each keychain costs the same whole dollar amount. Okay, so each keychain's the same. She bought between 6 and 9 keychains. So she has either 6 times something equals 32. She either has 7 times something equals 32. She either has 8 times something equals $32. Or she is 9 times something equals 32. Okay, so she bought 6 keychains, and each keychain costs the same. And we're going to do whole dollars. 6 times something equals 32. 6 times 6 is 36. 6 times 5 is 30, so it can't be that. 7 times 5 is 32. If each keychain was $5, it would be $35 total. How about 7 times 4? Well, 7 times 4 is 28, so it can't be that. Couldn't have bought um, couldn't have bought that. She bought how many? Let me see. 8 times $4 equals 32. That's true. Okay. How about 9? She bought 9 keychains. Each one costs the same. 9 times 3 is 27. 9 times 4 is 36. So turn about 9. So she bought how many keychains? She bought 8 keychains. Lots of times you're going to want to put 4 in here. And 4 is coming from the cost of each keychain. So 8, she bought 8 keychains. Each keychain was $4, and that gives us that 32, right? So she bought 8 keychains. This is very important that you're paying attention to the words, not just the numbers. All right, number 15. Sandy here buys a whole bunch of different types of flowers. She wants to arrange all the flowers in a bouquet. Each bouquet has the same number of flowers and the same type of flower. What is the greatest number of flowers that could be in a bouquet? All right. So the greatest number of flowers in a bouquet is blank flowers. This wants us to find the greatest common factor for 36, 9, and 18. So what we got to do is we got to not be lazy and find the factors for all of these. So 1 times 36 is 36. 2, and let's see if 2 can go into 36. 2 fits into 3 once, minus 2. 16. How many 2s fit into 16? 18. 8. And I don't have any remainder. So 2 times 18. And I know 3 times 12 is 36. How about 4? Let's see if 34. Can 4 fit into 36? Yes, because 4 times 9. 5, no. 6. 6 times 6 is 36. All right, so those are my factors for 36. Let's find the factors for 9. We got 1, we got 9, we got 3, right? The factors for 18, 1 and 18. We got 2, we got 9. You see how I'm trying to line up my factors here? We got 3, because 3 times 6 is 18. And 4, no, 4 is not a factor of 18. So the greatest number of flowers that could be in the bouquet, the greatest common factor with all 3 flowers, the roses, the daisies, and the tulips, is 9. Is 9 flowers. All right, last question, guys. So we got this character that's arranging 4 photos on a bulletin board. He puts the photos in rows. Each row contains the same number of photos. How many photos could be in each row? Well, we're just finding the factors of 4. And like always, 1 and the number are factors, and then 2, because 2 times 2 is 4. So 1, 2, and 4 photos go in each row. So that's the end of the mid-chapter checkpoint. A lot of this is just writing out the factors. You got to be precise with your multiplication. Let me know if you have any questions or if you need any extra help.